Welcome to Big Data Analytics Technique and Tools. Module 2, Why Big Data Matters. Companies such as Facebook, Amazon, and Google have come to rely on big data analytics as part of their primary marketing schemes, as well as means of servicing their customers better. Knowing what big data is and knowing its value are two different things. Finding what matters and why it matters is one of the first steps in drinking from the well of big data and the key to avoid drowning in information. Enterprise market that uses big data analytics. We have Google, we have Amazon, and of course, Facebook. Google uses the data from its web index to initially match queries with potentially useful results. This is augmented with data from trusted sources and other sites that have been ranked for accuracy by machine learning algorithms designed to assess the reliability of data. Google monetizes their search engine by working out how to capture the data it collects from us as we browse the web, building up vast revenues by becoming the biggest sellers of online advertising in the world. Amazon has leveraged its big data well to create an extremely accurate representation of what products a customer should buy. Amazon accomplishes this by storing each customer's searches and purchases and almost any other piece of information available, and then applying algorithms to that information to compare one customer's information with all of the other customers' information. Amazon has learned the key trick of extracting value from a large data well and has applied performance and depth to a massive amount of data to determine what is important and what is extraneous. The company has successfully captured the data exhaust that any customer or potential customer has left behind to build an innovative recommendation and marketing data element. Much the same can be said for Facebook, where big data comes into play for critical features such as friend suggestions, targeted ads, and other member-focused offerings. Facebook is able to accumulate information by using analytics that leverage pattern recognition, data mashups, and several other data sources such as user preferences, history, and current activity. Those data are mined along with the data from all the other users to create focused recommendations which are reported to be quite accurate for the majority of users. Big data reaches deep. Amazon, Google, and Facebook are huge enterprises and have access to petabytes of data for analytics. For example, we have the Hadron Collider at CERN. They are not the only examples of how big data has affected business processes. Examples abound from the scientific, medical, and engineering communities, where huge amounts of data are gathered through experimentation, observation, and case studies. CERN relies on those data to determine the results of experiments using complex algorithms and analytics that can take significant amounts of time and processing power to complete. Many pharmaceutical and medical research firms are in the same category as CERN, as well as organizations that research earthquakes, weather, and global climates. All benefit from the concept of big data. Small and medium businesses or SMB. Big data analytics can deliver value for multiple business segments. Small and medium businesses have access to scores of publicly available data, including most of the web and social networking sites. Several hosted services have also come into being that can offer the computing power, storage, and platforms for analytics, changing the big data analytics market into a pay-as-you-go, consume what you need. This proves to be very affordable for the SMB market and allow those businesses to take it slow and experiment with what big data analytics can deliver. Obstacles remain. The barriers of data volume and cost somewhat eliminated. There are still significant obstacles for SMB entities to leverage big data. The obstacles include the purity of the data, analytical knowledge, and understanding of statistics, and several other philosophical and educational challenges. It all comes down to analyzing the data, not just because they are there, but for a specific business purpose. Data included in big data include social networking information, sales lists, real estate listings, product lists, and product reviews. It can be gathered into structured storage and then analyzed. The gathered data proved to be a valuable resource for businesses that look to analytics to enhance their market standings. Big data, whether done in-house or unhosted offering, provides value to business of any size. From the smallest business looking to find its place in its market to the largest enterprise looking to identify the next worldwide trend. It all comes down to discovering and leveraging the data in an intelligent fashion. Place to experience analytics. We have the web. Analyzing website traffic. Example is the Bleco. This information can be very valuable for SMBs that rely on a company website to disseminate marketing information, sell items, or communicate with current and potential customers. Bleco fits the big data paradigm because it looks at multiple large data sets and creates visual results that have meaningful, actionable information. Using Bleco, a small business can quickly gather statistics about its website and compare it with a competitor's website. Key factor in the increase in data volumes. Sensor-enabled and instrumented world. For example, we make use of RFID tags. Vehicles equipped with GPS sensors. Low-cost remote sensing devices. Instrumented business processes. And instrumented website interactions. Data continue to evolve. Before 2010, managing data was a relatively simple chore. The typical enterprise now experiences a data growth rate of 40 to 60% annually. Online transaction processing systems supported the enterprise business processes. Operational data stores accumulated the business transactions to support operational reporting. And enterprise data warehouses accumulated and transformed business transactions to support both operational and strategic decision-making. The increased data growth rate will in turn increase financial burdens and data management complexity. This situation implies that the data themselves are becoming less valuable and more of a liability for many businesses or a low commodity element. The truth. More data mean more value, and countless companies have proved that action with big data analytics. To exemplify that value, one needs to look no further than at how vertical markets are leveraging big data analytics, which leads to a disruptive change. For example, smaller retailers are collecting clickstream data from website interactions and loyalty cards data from traditional retailing operations. This point-of-sale information has traditionally been used by retailers for shopping basket analysis and stock replenishment, but many retailers are now going one step further and mining the data for a customer buying analysis. Those retailers are then sharing those data after normalization and identity scrubbing with suppliers and warehouses to bring added efficiency to the supply chain. Big science and big data. Big science is now paired with big data. It is helping to redefine how data are stored, mined, and analyzed. Large-scale experiments are generating more data than can be held at a lab's data center, which in turn requires that the data be immediately transferred to other laboratories for processing. A true model of distributed analysis and processing. The validation of big data analytics can be illustrated by advances in science. The Biomedical Corporation Bioinformatics recently announced that it has reduced the time it takes to sequence a genome from years to days, and it has also reduced the cost. So it will be feasible to sequence an individual's genome for $1,000, paving the way for improved diagnostic and personalized medicine. Data and data analysis are getting more complex. One of the surprising outcomes of the big data paradigm is the shift of where the value can be found in the data. In the past, there was an inherent hypothesis that the bulk of value could be found in structured data, which usually constitute about 20% of the total data stored. The other 80% of data is unstructured in nature and was often viewed as having limited or little value. The perception began to change once the success of search engine providers and e-retailers showed otherwise. It was the analysis of the unstructured data that led to clickstream analytics and search engine predictions that launched much of the big data movement. Norm in processing unstructured data. Image processing for face recognition, search engine classification of videos, and complex data integration during geospatial processing. The successful processing of large volumes of unstructured data led other industries to take note, which in turn has led to enterprise mining and analyzing structured and unstructured data in conjunction to look for competitive advantages. Behavioral analytics, a process that determines patterns of behavior from human to human and human to system interactions data. It allows the creation of a more predictive model. It requires large volumes of data to build an accurate model. The behavioral patterns can provide insight into which series of actions led to an event, that is, a customer sale or a product switch. Once these patterns have been determined, they can be used in transaction processing to influence a customer's decision. Behavioral interactions are less understood, and they require large volumes of data to build accurate models. This is another case where more data equal more value. This is backed by research that suggests that a sophisticated algorithm with little data is less accurate than a simple algorithm with a large amount of data. Evidence of this can be found in the algorithms used for voice and handwriting recognition and crowdsourcing.